my ID is 24CS074. So today we are discussing on the topic of multi-core processor architecture. So here we can see the multi-core processor overview. Let we can discuss on the definition of multi-core processor. Then a multi-core processor contains multiple cores inside a single CPU. So each core can execute instructions and independently. So if we can discuss the earlier scenario, then at the earlier time CPU had only one core, but due to limitation like heat and power, we shifted to multi-core system. So in this animation, each block represent a core data flow between them. So this enable parallel execution, which improves performance in tasks like gaming, AI, and multi-core tasking. So let me discuss the feature of that animation. So we are seeing the Intel Core i7 CPU architecture. So it can it has these all cores in a single CPU chip. If we are discuss on the Ryzen, then it is similar to almost Intel. And if we can see of the mobile CPU, then it is different that we can see. And if we are going to desktop, then it looks like that. So we are going to discuss the multi-core processor overview. Then we can see the basic definition of it. What is the key concept of this? We can see that, and why is matter, that we can already discuss that gaming, AI, video editing, multitasking, all demand parallel compute, etc. So what is multi-core processor? So basically this is its definition. Where is CPU? So these all are basic question to introduction to multi-core processor architecture. So I implement the many features like if heat, then how is the animation look like that? This is heat, and we are seeing this portion. It's introduction about task per second. So currently at this scenario, we can see that coding the speed, 65,000 something tasks per second are performing, and CPU uses is this. So this data are basically on my computer. So it is redirected by my database, and we can see this all four cores and its performance. So if we are increase its speed, so we can see that CPU uses its maximum performance, and we can also see the tasks per second that also increased, that we can see. So if we maintain its speed and see the structure, so we can also see the structure as well as. So we are going to next phase, that is code. So
this is a single core. It contains the ALU, control unit, and registers.
So basically I implement the voice system, that is we can see here. So basically which type of this space introduction that. So basically page 2, each core is like a mini CPU containing ALU, control unit, register, or L1 cache. When I click the components, so you can see that these or these all are this is control unit, this is arithmetic logic unit, and this is L1 cache. We can see the task of L1 cache, that is fast memory inside core. We can see all the components of tasks. So these all features are same. We can see for Intel Core, we can see for Ryzen. So basically it is same for the all. And other option is unique, that that we can give the answer by some one question, what does the ALU do? Then we can more improve our knowledge about ALU by these, and I can answer these and simply close that. So these all are feature working in each pages. So when I click on the tool, then it is automatically tour of the whole model like that. So simply it starts is that. So we are moving to instruction cycle. Then third page is instruction cycle. So
this shows the instruction cycle: fetch, decode, execute, and write back.
So basically, instruction cycle has these three mainly tasks that is fetch, decode, and execute. So if instruction cycle, there are four stages in this instruction cycle. That is fetch, decode, execute, and fourth is write back. So if we see the structure of Ryzen, then it is looking like that. If we are seeing the mobile CPU, then it looks like that. So when we are going through its working, then this data flow is continuous streaming from this instruction cycle like fetch, decode, and execute. And if we speed the fast, and so all our working is fast. So we are moving to cache memory.
This is the cache hierarchy from L1 down to RAM.
So this cache hierarchy, if here we see the cache memory hierarchy, like labels L1, L2, L3, and last is RAM. So basically L1 is fasted and inside the code, and other L2 is medium, L3 is shared, L3 is shared, and last RAM is slow. So I implement the cache hit and cache miss. This feature is both are. So cache hit is for fast path and cache miss is for slow path that we can see. So if we are going to the fifth page, that is parallel processing.
This demonstrates parallel processing using multiple cores.
So we can see the parallel processing. This page demonstrates parallel processing. I can run task simulation, task enter system, scheduler, distributed cores. So there are two types of this parallelism: task parallelism and the data parallelism. So here the CPU has these all parallel tasks ongoing. If I can convert it in single, then we can see also that what I can do in multiple. So if we are going to match our page,
this shows cache coherence between different cores.
So basically this when I select and drag, then I can move the all cache coherence in 3D map, and if I scroll with the mouse, then I can see with the zoom. If I slow the speed, then we can see that. So basically, what is cache coherence? When multiple cores access same data, we need cache coherence. So MESI protocol ensures consistency. So basically, what is MESI? When modified, exclusive, shared, and invalid. So we can see that in this question. So modified, exclusive, shared, and invalid. So it is correct. So what is cache coherence? We can study by this. What does MESI stand for? We can also move for this. In the desktop workstation, this all cache coherence is greater than the Intel Core i7. So we can move to the interconnect.
This is the interconnection network routing data between cores.
So what is the interconnection network? Then we can discuss cores communicated using the boss, ring, and mesh. We can see the animation. In this animation, data packets move between cores. That we can see that. If I flow the fast rate, then we can see more accurately. So this is important for communication and the performance. So interconnection is the most probable part. So next page is Amdahl's law. Then see that what is Amdahl's law.
This explains Amdahl's law for calculating theoretical speed-up performance.
So this explains the performance limitation. We can see that this green line and this red line. So performance in Amdahl's law. So Amdahl's law quantifies the theoretical maximum speed up of program parallelized on a n course. The serial fraction dominates at scale. So basically, in the Amdahl's law, it states that even with many cores, speed is limited by serial part. So we can study more about Amdahl's law by these questions. So it is more accurate of a sharp mind. So we are going to next phase, that is memory interface.
This shows the memory interface and data bus communicating with RAM.
So this is memory interface. Memory controller manages the data flow, and for this important concept, bandwidth and latency. In this animation, we can see the data read and write between the CPU. Then we can see this both. This is CPU and this is a read-write operation. So it is not different in mobile desktop or laptop or Intel Ryzen, etc. So basically, it describes the main memory interface. What process in the memory interface due to multi-core process architecture. So we are partitioning the multi-core processor architecture into 10 parts. So first we can see the overview. Then we are learning about cores, what is core, and single core, multi-core, and why one CPU chip has many cores. Then we can see the instruction cycle, what is instruction cycle, what is the usage of this. So basically, at the last page, we can see the application of this multi-core processor architecture in the our current scenario.
These are real-world applications of multi-core processors across different scale devices.
So as we discussed past, application in future is on the basis of gaming, or we can say that AI in machine learning, in the cloud computing, or mobile processors. So for the AI ML, we can use this concept to training the neural network requires billions of parallel multiply accumulate operations. CPUs handle AI orchestration, or it is also helpful for GPUs. So how can it help in cloud computing? So a single AMD server CPU has up to 192 cores. So we can imagine that how it works and how it helpful for this our current scenario. So in this my animation, in this my whole website, we can see all the feature that is rotation of 3D model, or we can see that by zoom, by the control feature, we can speed we can maintain our data speed, or structure versus working mode. We can also, if we want to see structure only, without data, then we can see this option. So we can see only the structure of it. So we can see also these all tasks, that is tasks in each or miss or etc by the voice. So these all for the multi-core process architecture. Thank you.